This modular building block is a simple example of a highly engineered part. Highly engineered parts are driven by parameters and expressions. The design intent represented by sketch constraints, sketch dimensions, and other equations controls how the part behaves when parameters change. Create these types of parts carefully using expressions, fully constrained sketches, and sound associative practices. In the model history, notice that I've renamed datums, sketches, and features to clarify their function. When you design highly engineered parts, plan and create expressions before creating features. For example, I define N1 and N2 as the number units to create in each direction. And I define expression U as the unit square dimension. Use expressions instead of constants when creating sketches. Fully constrain the base sketch using the predefined expressions U, N1, and N2. Use expressions to create other features such as this pattern. For example, enter N1 and N2 for the count in each direction. Enter U as the pitch distance. NX stores the expression for the feature parameters, and not just the current value. Parameter-driven parts can be the basis for a family of parts. For example, if we change the value of expression N1 from 4 to 2, the part updates. Remember that you must define expressions using the proper units. I defined N1 and N2 as unitless constants. And I defined expression U as a length quantity with units of millimeters. Even a simple part like this one shows how you can create highly engineered parameter-driven parts. To summarize, when you design highly engineered parts, start by creating expressions. And then use those expressions to define sketch dimensions and feature parameters.